Hello everyone, welcome back to our lectures. Today we will be talking about peptides, and I have a beautiful picture of a peptide below. This peptide actually, of course, peptides are formed through the process of amidation when the carboxylic group of one amino acid combines with the amino group of another to form the peptide bond. So this is basically the peptide bond here. So the peptide bond is known. This is C, double bonded to O. This is oxygen, and then connected to the N of another amino acid. This is H. So this is typically the amide group. So this is the peptide bond. So this peptide actually, this is actually alanine on this side. This is glycine. So this is actually an Ala-Gly-Ser. I just decided to use this to make an intro page at this point. Okay, let's immediately start up our lecture. Today I have a beautiful quote from someone that I adore so much, someone who contributed a lot to this, to mankind, of the blessed memory, Marie Curie. She says, first principle, never to let oneself be beaten by persons or by events. Whatever you want to do in this life, do not allow yourself to be beaten down, to be discouraged by persons or by events. You need to be driven and pursue your passion. Marie Curie was a Polish and French physicist and chemist. She won the Nobel Prize twice in 1903 with her husband Pierre Curie and Henri Becquerel for their pioneering work in the concept of radioactivity. In fact, she was the one that coined the word radioactivity. She also won another Nobel Peace Prize in chemistry. In fact, the first one in 1903 was in physics. She later won another one in chemistry for her role in the discovery of two elements, polonium and radium, and that was in the year 1911. So she stands as the only person that have won Nobel Prize of Science and Discovery in two different fields of chemistry and the field of physics. Now, she's the first woman to become a professor at the University of Paris at a time that women's rights were not what we have it as at now. She also, under her watch, the first studies were conducted in the treatment on the use of radioisotopes in the treatment of neoplasms. And during World War I too, she developed a mobile radiography unit to provide X-ray services to field hospital. And you know what happened? While doing this, she had a lot of exposure to radiation, and as a result, she got sick with aplastic anemia from the exposure of those various radiation, and she died at the age of 66, giving her life to make sure that mankind is surviving today. Marie Curie of the blessed memory is one of the greatest women that ever walked this earth, and I pay my profound tribute to her. All right, let's immediately start the lecture. Learning objectives. I have three learning objectives here. We're going to know and draw the reactions for the formation of peptides or peptide bond formation. Oh, I wanted to say that was okay. Or peptide bond, I have it here. So draw the reactions for the formation of peptide, or you can say peptide bond formation, anyone, because you form peptide bonds are what holds amino acids together to form a peptide. Now we'll draw and write the reactions of oxidation of cysteine. Cysteine is a sulfhydrate containing or thiol containing amino acid that forms a disulfide bridge, which actually plays an important role in the secondary structure of protein. We're going to see that. And then finally, we're going to describe the uses of important peptides. And three important peptides we're going to be looking at here are the vasopressin, the oxytocin, and the adrenocorticotropic hormone. And these are the objectives of this class. Let's immediately take it off from there. Now, we have a lot of terminology that we need to get ourselves acquainted before we dive into the real structural drawing of these peptides and peptide formation. So what are those? Number one, what is a peptide? A peptide is a polymer of amino acid containing about 2 to 50. A peptide contains about 2 to 50 amino acids and joined together by peptide bond. A peptide bond is an amide bond. Of course, I told you already here, the amide bond is formed. We got some of this knowledge when we talked about the amines and amide. When the carboxylic group of one amino acid reacts with amine of the second one, they form a peptide bond. And there are different types of peptides we're going to be looking at. Oligopeptides. Oligopeptides are polymers of amino acid that contain about 2 to 14 amino acid units or residues, of course, joined together by peptide bond. So oligopeptides can be dipeptides when they contain 2 amino acids. They can be tripeptides, 3 amino acids. They can be tetrapeptides, 4 amino acids. They can be pentapeptides, hexapeptides, and then the name goes on. And of course, when it becomes so big, from 15, perhaps from 15 to 50 amino acids, we say they are polypeptides. So polypeptides are those polymers of amino acids that contain about 15 to 50 amino acid residues joined together by peptide bond. And then what is a protein? How does a protein differ from a polypeptide? A protein is a much bigger polypeptide. So a protein is a polypeptide that contains more than 50 amino acid residue, of course, joined together by polypeptide bonds. And then what is amino acid residue that I've used? I've used amino acid residue here. Look at, I've used this amino acid residue here. What does it mean in the first place? An amino acid residue is simply an amino acid that is part of a peptide or a protein chain or backbone. That is what we call a peptide. That's what we call amino acid residue. When it is a part, of course, if you have if this is an amino acid that is joined together by an amino acid, joined by an amino acid. So assuming this is my tetrapeptide, a tetrapeptide will have, let me use a different color. We have the amide bond holding. So this is also another amide bond. This is also an amide bond. And this amide bond is actually what we call the peptide bond, holding them together. So what is a peptide bond or peptide linkage? Just like I just said. So a peptide bond or linkage is an amide bond between 2 amino acids. Any 2 amino acid is connected by that connection. That connection between them is what we call the amide bond. Or we say it is the peptide bond or peptide linkage, depending on which word you want to use. Now it is formed when the amino group of one amino acid reacts with the when the amino group of one amino acid reacts with the carboxylic group of another amino acid in a process of what? Amidation. Amidation, of course, this is a polymerization reaction. It's actually a condensation polymerization whereby water molecule is lost. Condensation polymerization. So like we said, those peptides are just polymers of amino acid, whereas the amino acid are monomers. That means the simplest unit. So the polypeptide backbone, what is it? Or chain, is the backbone of the protein or the polypeptide. It is formed by amino acid linking together by peptide bond, of course, like we said. However, it does not include the side chain of those amino acids. Now, so it is the NCC backbone. Remember, every amino acid is made up of the NCC backbone. NCC means this is the alpha amino group, the alpha carbon, and the alpha carboxylic group. It's NCC. So this NCC will be joined together. Okay, if this is the first amino acid, it's going to be joined together through a peptide bond to another one, to another NCC. So this is typically what we call the backbone. So the backbone does not include those aru groups that are connected to the alpha carbon. Remember, this is the alpha carbon, this is the alpha carbon. Just that backbone is what we call the polypeptide chain of the backbone. Now, by convention, peptides are drawn or written with the N-terminal residue of the amino acid to the left and the C-terminal residue of the amino acid to the right. So it is written by convention from the N to C. So it starts with the N and ends with the C. N means it starts with the amino acid side, and that will be the amino acid at the beginning, and C will be the amino acid at the end. And we're going to see this the moment we get into the next thing, which is the peptide bond formation. So peptide bond formation enables amino acid to make polymers by forming peptide bonds or forming amide bonds or peptide linkages. Yes, they help amino acid to make peptide bonds by forming, they help them to make polymers of those peptides. Like I said, they are polymers. So it enables amino acid to make polymers. And to make these polymers, they must form this amide or peptide bond or linkages that hold them together. And of course, this process is an amidation reaction process, or you can say it's a condensation polymerization, because in condensation polymerization, water is usually lost. Water is lost in the process. Let's see what is happening here. Now, this is an amino acid. This is the first amino acid. I'm going to use AA. This is the amino acid 1. This is the amino acid 2 coming together to form peptide bond. Of course, what is going to happen? This one is not going to react. This one is outside. It's not going to get involved. What are the two getting involved? This carboxylic group and this amino group are what is getting involved. So what is happening here? Now, this guy is going to lose these two hydrogens, and this guy is going to come and join this place. Look at what happens. This guy loses two hydrogens here, and this one loses this oxygen. So if you have one oxygen plus two hydrogen, that's going to form 1 mole of water. And when they now join together, this process is amidation reaction for the forward reaction here to form the peptide bond. So look at what happens here. This is an amide group. This is the amide group. And the connection between this carbonic carbon, the carbonic carbon of the amino acid A and the amino group of the amino acid B or 2. Okay, I say amino acid 1. Let me work it back because I use 1 and 2, not A and B. So if you look at the connection, the carbonic carbon, or you can say the carboxylic group, which one you want to say, of the amino acid 1 now combined with the amino group of the amino acid 2. This to form this amide bond. So this particular bond, I think this should be a pink color. I'm a little bit colorblind, is what we call the peptide bond formation. So what we have here now is a peptide. In fact, this actually is a dipeptide. This is a peptide bond. This is a peptide. And a peptide that has two amino acids is actually a dipeptide. This is a dipeptide. Usually the dipeptide stays together. Yeah, this is a dipeptide containing two amino acids. However, most peptides can easily be broken down by hydrolysis. And this is usually done by the enzymes in the digestive system, the peptidases or the proteolytic enzyme. What do? Is they come back and act as a machete to cut this bond, to break it down to amino acid. And what they use to do that is they use water molecule to break it down. And the opposite reaction here is the hydrolysis reaction. So now, like I said, let us now try to understand every nitty-gritties of this peptide bond like we introduced, or like we talked about in the terminology. Now, the peptide bond, what I have here now is, let's see, how many amino acids do I have here? First of all, I have R1. Tell me this is the first amino acid. This is the second one, R2, R3, and so there are 4 amino acids. So this is technically a tetrapeptide. I'm going to use a different color there. This is a tetrapeptide. Oh, this is not coming out well. Okay. Tetrapeptide. Now, so you see, because these things are all unique, telling you they're all unique, though in this case I use the generic R to represent them. So in this peptide bond, so the peptide bond is written, like I said, from the N terminal to the C terminal. This is the direction towards the right of the peptide bond. Now you see, let's see what happened here. It started with an N. Okay, let me try to use a different color now. The N started this amino acid here, this peptide, and ended with a C. And that is why this amino acid at this juncture is what we call the N-terminal amino. So this is the N-terminal amino acid. And this is the C-terminal amino acid. Because this amino acid ended with the C, which is the carboxylic group. And this one started with the amino group. That's what we call it the N-terminal. So, peptides or peptide bonds are written from the N-terminal amino acid to the C-terminal amino acid. And of course, now, how do you know the total number of peptide bonds formed in the total number of peptide bonds formed in a peptide is calculated by 1, the number of peptide bonds equal to the number of amino acid minus 1. I told you that this is a tetrapeptide. What it means, it has 4 amino acids. If you want to know the total number of peptide, it's going to be 4 amino acid minus 1. So if you do 4 minus 1, you're going to have 3 peptide bonds. That's what we have here. So if you have 3 peptide bonds, what does that tell? Let's see. Let's count it. You see, this one joins with this one here to form the first peptide bond. This is peptide bond 1. This is peptide bond 2. And this is peptide bond 3. So if you know the amino acid sequence, the number of amino acids in that peptide, you don't need to draw it to actually know the total number of peptides it needs to form. So you should be able to know how to do all these things and draw it for me. Like I said again, you should be able to draw and label or pass. So like I said, this is a peptide bond. This is a peptide bond. This is an amide bond. And this is another amide bond. So you should be able to draw these things and label all parts of this peptide. And again, another important thing I need to say in this page is this, is that like I told you, that this peptide backbone is formed by NCC bond. Look at it. The first amino acid is NCC, end. The second one, NCC. The third one, NCC. The fourth one, NCC. It flows by that. And here, if I want to label, the backbone, I'm going to label it without including, so the backbone, I'm going to label it without including the backbone. So it's going to be just this, without including not including the backbone, without including the arrow groups. So the arrow groups are not included in the polypeptide backbone. It is just the NCC from the N terminal to the C terminal is what you need to label. And let's take some examples in the next few pages. But before we do that, let's talk about the order of linkage. See, the order of linkage of amino acid is very important in protein biochemistry and polypeptide biochemistry because it gives the unique identity to that particular peptide or polypeptide. So it results in different peptides even when they have the same amino acid in them. Remember, the sequence is different, but it's the same. Let's see the first one. The first one here, this peptide is made from an alanine and a glycine. This is alanine, glycine. When they join together, they form alanine. No, not a glycine, sorry. I walk it back, sorry. This is alanine and cysteine. What is all about with glycine with me? Alanine and cysteine. So this forms the alanine cysteine. Now, this alanine cysteine is unique on its own because there's the sequence of this alanine to cysteine amino acid sequence that it has to make up this. Of course, this is a dipeptide because it has two amino acids. This is a dipeptide. Now, if you change the sequence whereby it is made from cysteine comes first and alanine, what you're going to have is cysteine alanine. The cysteine alanine is different from alanine cysteine, and their function in the body is going to be totally different. So the sequence of this amino acid is very, very important and gives them that unique identity. And in fact, this actually determines what we call the primary structure of proteins and polypeptides. So just this is very, very important to stress. Now, let's take some reflection questions here. It says, draw the tripeptide with the amino acid sequence below at the physiological pH. What it means is that, remember, every amino acid is ionized at physiological pH if they have ionizable groups, apart from the carboxylic and amino groups. Now, it says indicate the charge, label the peptide bonds, the N and C terminals, and circle the polypeptide backbone. It's just to ask us how many backbone does it have. We can start with that one. So how many peptide bonds, not backbone. How many peptide bonds does it have? So if you want to start with that, that's the simplest. We can start with that. There are 3 amino acids. So to know the number of peptide bonds is important. It's going to be, of course, 3 amino acid minus 1, like I gave you in the formula. So it's going to have 2 peptide bonds. You might just do that so that you can check that when you draw it. So it will have 2 peptide bonds. So let's start. The first thing we have to draw is alanine. Now, I tell students the best way to draw these things is come with your NCC. Alanine is non-polar. It will have the methyl group at alpha carbon. So it's going to start. I'm going to start with the NCC. So I'm going to say N, C, and C. That's what you want to do first. This is the first amino acid. Of course, this one is going to be ionized because we are drawing it at physiological pH. And then if this is glycine, we have, this is the alpha carbon. Remember, glycine will have this. And then, therefore, this one will not be the carboxylic group. But you're not going to finish it because it's forming another bond with the second one. So it's going to form, okay, let me use a different color. It's going to form the peptide bond with the next one, which is what I've drawn this one. It's going to form with glycine. So glycine is going to start again with another N. So it's going to be another N, C, C again. Now, of course, every peptide bond, hydrogen will be used to complete the octet of nitrogen here. You have to have 3 bonds and one lone pair. So, but you don't need to put the lone pair. So I'm going to put the H here. Then we're going to glycine. Glycine, the alpha carbon, all of them have the hydrogen on this. And then for glycine, it has only hydrogen. It doesn't have any other arrow group. So you're going to put that hydrogen there immediately. You're going to put it there. So it has the hydrogen. I know why I'm trying to make that long, so it's not going to distract my... Okay. Then, of course, this is the carboxylic group, but you're not going to finish it because it's going to be connected to the serine. And of course, okay, now I'm going to pull the peptide bond. The peptide bond will be, I'm using blue for it. So if I put that again, then I'm going to have another N, the last one. So this will be N, the last N, C, C. Of course, this hydrogen this nitrogen need the hydrogen here to form the second peptide bond. And then, finally, this alpha carbon always have a hydrogen on top. Then below, you are talking about serine. Serine has CH2. Okay, wait, let me make it out a little bit longer. So serine has the CH2, and then it has an alcoholic group OH. This is serine. And then this is where it ends. What it means is that you're going to draw the carboxylic group completely at this point. So this is the tripeptide. This is a tripeptide. We've drawn it below. Now we're going to begin to label. It says at physiological pH. So if we're going to indicate the charge at physiological pH, okay, let's first of all do the charge. What is the charge? The charge of this is that this is neutral. This is polar and neutral or polar uncharged. So it's not ionized. This is non-polar, it's not charged. So the only charges we have here is this plus 1 and minus 1. And when they cancel out, their charge is going to be 0. So it's not charged. This particular tripeptide is neutral. Good job. Having done that, it says label the peptide bond. Let's label the peptide bond. If I use the same color I used earlier to label it, okay, let me use this. So look, this is the, remember it has 2 peptide bonds. Let's see, we only have 2, which is correct. It has only 2 peptide bonds. So this is the peptide bond. So this is the peptide bonds. Now this is the peptide bond. We'll label the 2 peptide bonds. Okay, what else? It says label the peptide, indicate the charge, label the peptide bond. We've done that. The N and C terminal. Okay, what is the N terminal? Let's do that. So the N terminal will be the amino acid that starts with. So the N terminal is this amino acid here. You can circle it yourself, or you can use, okay, let me just use this to do it. So this is the N-terminal amino acid, which is alanine. So alanine here, the first one, is the N-terminal amino acid. So this is the N-terminal. And the C-terminal is going to be this amino acid, which is serine is the C-terminal. So the C-terminal here is going to be this guy. This is the C-terminal amino acid, which is the serine is the C-terminal amino acid. Alanine is the N-terminal amino acid. And then what else? It says circle the polypeptide backbone. And how many peptide bonds does it have? So we've done that. It has 2 peptide bonds. We've already established that one. We did that one early enough. We did that one. It has this. So the only one left is, it says circle the polypeptide backbone. Yes, I'm going to do that. So I'm going to do that with a yellow. To do that with a yellow, remember I told you, it does not include, what did I say? It does not include the, okay, that's okay. I shouldn't have cleaned it. Okay. It does not include the side chain. So let's look at the side chain. The side chain of this one is methyl group. The side chain of this one is hydrogen, and the side chain of, so we're going to exclude it in this. So if I'm going to use this to circle it, let me see. If I use yellow to circle it, what I'm going to circle is that I'm going to make sure that I don't get the side chains. I can get every other stuff, but I don't need the side chains. And then I can get these ones. It doesn't matter. This yellow circle is the peptide backbone, excluding the side chain here, which is metal. The side chain here is hydrogen, and the side chain here is CH2OH. So this is the polypeptide backbone, which is that NCC bond in a peptide. All right, we now move to the next problem. In reflection 2, almost the same thing with the other one too. It says draw the tetrapeptide. Oh, in this case, we're drawing tetrapeptide with the amino acid sequence below. This is the amino acid, cysteine, lysine, alanine, and serine. It says a physiological pH, which indicate the charge, and then label the peptide bonds, and then the NC terminal. Not a lot to do in this case. So let's start with cysteine. Start first. Remember, how do you do it again? NCC format. We start again. The NCC is the first thing you put. Your NCC, cysteine, of course, this will be the N terminal here. Will be this ionized, the physiological pH. Okay. And then the C here is the alpha carbon. For cysteine, you know what? Cysteine is the only sulfhydryl containing amino acid. So it's going to have this. And then it has the SH, sulfhydryl group. And of course, there'll be a hydrogen here. This is the first one. Now, you're going to have this carboxylic. Then you're going to have this connected to the second one. The second one is what? Lysine. Lysine is an amino is a basic containing amino acid. Is a basic amino acid or basic and polar amino acid or positively charged. So if you connect it here, we're going to have this here, and then of course you're going to have the NCC. The NCC of this one, of course, there'll be hydrogen on this alpha carbon. Here we now have that long chain. You can make it the long chain or you can make it short. So I'm going to try to write all of them. It's okay. I'm going to write all of them. CH2. There's another CH2. He has about 4 of them. CH2, CH2, and then he has NH3. Oh, no, that 3 didn't come out well. Let me see. NH3 plus. So 1, 2, 3, 4. So yeah, this is the what? This is lysine. So I've drawn this. This is lysine. This is the side chain. Then we come to alanine. Alanine just has methyl group. Remember, we're going to put the next peptide bond. The next peptide bond. Remember, there are 4 amino acids, so it's going to have 4 peptide bonds. So we've done this. We're now putting alanine. In alanine, we're going to do our NCC again. So it's going to be N, C, and C. So what it means is that we're going to have this here. Of course, you're going to complete the hydrogen with this one. You're going to now do, this one is alanine. Alanine has the methyl group. Remember that? And then you're going to have this. And then you're going to put the last peptide bond connected to which amino acid. We've done this one. The last one is serine now. For our serine, it's going to be another NCC. So it's going to be N, C, and C. Here, you're going to put the hydrogen to complete this one. There's a hydrogen here. But remember, serine, of course, has the CH2 and the OH. And again, this now becomes the last one, which is the N-terminal amino acid. So if you see, since there are 4 of them, it's going to have 4 peptide bonds. Your peptide bonds will be 4 minus 1 equal to 3 peptide bonds. So if you want to know if you're correct, we have 1, 2, 3 peptide bonds showing that we're correct. So let's see what we have to do. So at physiological, what is the charge? Let's look at the charge. There's a charge here. There's a charge here. Look at this one. There's a charge here. Now, if plus 1 cancels, if minus 1 cancels plus 1 is 0, but this charge is going to remain. Therefore, the overall charge of this guy is going to be a plus 1 charge. It's going to be a plus 1 charge. This particular amino acid is charged because, okay, let's recap again. 1 plus plus 1 plus will give you 2 plus. 2 plus minus 1 minus 1 will give you what? Will give you 1 plus. So this has a charge of plus 1 because it contains this basic containing amino acid lysine, or you say positively charged amino acid. And that's the first thing. So we've done this. It says label the peptide bond. The peptide bond, there are 3 of them. We already indicated it. So there are 3 of them. So this is a peptide bond. This is a peptide bond. And this is so this is the peptide bonds. Peptide bond. Peptide bonds. Yeah, this is just the peptide bonds. And then what else? We've labeled the peptide bond, and it says the N and C terminals. Let's label the N and C terminal. The first amino acid starts from here. You can decide to label all of them, but I want to just make it a little bit clean. So this is the N terminal. It started with the N, and the N terminal amino acid. I can ask you what is the N terminal. The N terminal amino acid, of course, is cysteine. It's cysteine. And then the C terminal amino acid is this one. Starting from here, this is the C terminal. This is the C terminal. C terminal amino acid. And the C terminal amino acid, of course, is serine. You can also look it from here. It is serine. And that is all we've been asked to do in that problem, of course. All right, we now go to the next stuff to finish up. See, oxidation of cysteine. Cysteine is the only thiol or sulfhydrate containing amino acid. I've said that a couple of times here. It can easily be oxidized to form disulfide bridges. And I remember I made mention of this when we talked about the thiol groups, in module 13 or thereabout, when we talked about the thiol groups and the formation of disulfide bridges. Now, these disulfide bridges are important in maintaining the secondary structures of protein. Remember, this disulfide bridge is a covalent bond. It's a covalent bond, and it is important in the secondary structures of proteins or peptide. Secondary structures of proteins or peptide is very, very important when it forms these disulfide bridges. So look at what is happening here. This is the amino acids, cysteine and another cysteine coming together to react from here. So when these two combines together, what happens? They release one molecule of water, because if this hydrogen goes, combines with this oxygen to form one molecule of water. So that's what you're losing. You're losing this hydrogen. It combines with water to form one molecule of water here. And then both of them join together to form the disulfide linkage. And I said again, this is very important in maintaining the secondary structures of proteins and polypeptides. Now, the last thing we need to talk about here are some important peptides we need to look at. We'll start with the vasopressin and oxytocin. Vasopressin and oxytocins are classified as non-peptide because they contain 9 amino acids in their peptide chain. Of course, both of them are produced by the hypothalamus of the brain and they are secreted by the posterior pituitary gland. Both of them have disulfide bridges that join 2 of the peptide chains together. Now, the structures are similar. The only difference in these structures is only in their 3rd and in their 8th amino acid residues. Now, vasopressin is also called antidiuretic hormone because it plays an important role in the regulation of volume and the osmolarity of the urine. It helps in controlling the amount of urine that is produced by the kidney. Now, on the other hand, oxytocin itself is very important, particularly in reproduction. So oxytocin induces uterine contractions and also stimulates lactation of the mammary gland. So it has a strong effect in contracting the uterine muscles. Very, very important, particularly in giving birth of a child. And it also stimulates lactation of the mammary gland to produce milk for feeding the newborn. All right. And then the last thing we're going to be talking about, but not the least here, will be okay, let's look at the structure before we talk about the adrenocorticoid. So look at the structure of this guy. So these two structures, I made up these structures myself actually. This is oxytocin and this is vasopressin. So if you look at the oxytocin and look at both of them contain 1, 2, 3, 4, 5, 6, 7, 8, 9 amino acids joined together. You see the amino acid 6 here, both the 6 and the first one contains cysteine, and this cysteine are joined together by these disulfide bridges to maintain their structure. Remember, when you break this structure, they lose their function. This is how they want to exist. So now the difference between oxytocin and vasopressin lies in the amino acid number 3 and amino acid number 8. Here it has isoleucine, here it has phenyl for vasopressin. In oxytocin, in number 8, it has leucine, whereas here it has arginine. That is just the difference between these two amino acids. So you should be able to make these connections and understand this, and particularly know their functions. That is what I needed to know, particularly in the exam. And finally, the adrenocorticotropic hormone. This is the last thing we're going to be talking about. The adrenocorticotropic hormone is, of course, you call this an oligopeptide. Oligopeptide contains from what? From 15 to 50 amino acids. It is synthesized by the pituitary gland and it contains 39 amino acid residues. Now, it is just a long chain. It does not have any disulfide bridges linking them together. Now, what is the function? It regulates the production of glucocorticoid. Glucocorticoid is example is a cortisol cortisol, which plays an important role in what? In the metabolism of glucose. And then androgens. Androgens are sex hormones. So it regulates the production of both the glucocorticoid and the androgens from the adrenal cortex. And like I said, this is the amino acid sequence. You don't need to memorize this, but just know that you just need to know the basic structure of 39 amino acids held together by the peptide bonds, and it does not have any disulfide bridges. Of course, now the amino acid at the N terminal here is the serine. Of course, this is the N terminal, and the one at the C terminal here is the phenyl. This is the C terminal amino acid. Of course, I drew them. Okay, I should have drawn this one at ionized pH. I missed that, but my intention was to draw both of them at the ionizable pH, the way they exist in the body. And having said that, we've come to the end of this lecture. Thank you for listening. Bye.